everyone I think can get wowed by technology. It comes in the fact though, how do you take that and change it in which that you have a client that's willing to embrace it and pay for it, right? I mean, that's the challenge. That's the business side of it. So we need to continue to find the way to talk about that return on investment and how this technology will impact our clients. And it's there. It's just that's another place that we probably is. If I use a broad stroke on engineering, as maybe that's not our strongest spot, is to be out to promote and sell along those lines. Such as maybe if it was a great new technology inside of a software space, or they can market and brand that quick and get it out to where that industry feels the need that I need to have that. For us, that's not a comfort zone as our industry, but we're going to get there and then understand better how to help agencies procure these services. You got to help them to set that up so they can build it into industries that haven't changed a lot over the last years.
I'm Mike Paralak with Planet Underground TV.
And I'm Ted Anderson with North Shore Gas Company. New technology is affecting every aspect of our lives.
But can new technology help us avoid underground utility damage?
Or do we have to change our approach to damage prevention?
Or do we need to do both? The fact is, damages are going up.
As digging increases, so do damages.
In this episode, we ask, can this trend be reversed?
Planet Underground TV is only made possible with the support of our sponsors.
In-Trend,
HBK Engineering,
and C-Scan.
As an employee of a utility company, my job is to get the best available information to the excavator.
And I think we can all agree that the future of damage prevention is going to be dictated by the utilities.
The understanding of utilities towards the importance of infrastructure 15 years ago was much less than it is now. I would get the sense that the primary mission, and this is the case for a utility, is to providing a service to its customers. And it's not so much to worry about a plastic or concrete pipe in the ground. That to them is almost a necessary evil, a means of providing that service, but not the primary mission. Or recently, I think it's become more of a focus to them because now they're starting to understand the impact of other utility work in that area, how that can impact their facilities, how that can impact them. But also, as they start to expand their service from a customer base of 15 or 20 years ago, now to a customer base and growing population that we have now, it's much easier to access that infrastructure with better records and better mapping of the utility.
I think if a lot of these utilities are identified and their location is known, a lot of the tickets that come in they can get cleared much faster, much easier. I think there's a lot of efficiencies that can happen if we know where the utilities are and we can be accurate with our maps of these underground utilities. I think we've had these discussions all day long. It's very universal that people want to know where the assets are so they can better manage them.
Part of the discussion, one of the panel I was with today, we discussed that, a centrally managed database basically of all this utility information. Well, one of the advantages that comes out of the question, Dave, that you just had was, to that point of the central location, you're now taking a process in which maybe where the one call system has been identified as this part of the process that's up against construction. It's within hours of construction, arguably, and during construction. Well, with this now, the ability for that data from past locates and existing infrastructure maps and held in this database, as engineers are planning it and are designing it, you could have connections to where, when will that project being designed, its magnitude, its scale, when will that be hitting its construction phase? And then you would have this more comprehensive set of data that gives you what will be not only the projects that are happening today, but then also seeing all of the projects that are being designed at that moment, knowing those will be coming on the construction line, whether it be 6 months to a year later.
A centrally managed utility location database may relieve some of the pressures of one-call locating, which occurs just hours before construction begins. Locating can be the first step in collecting data if the results of each locate are recorded.
The roads get, some intersections or streets you try and locate, and there's so many different utilities in the ground, and it just makes it harder to locate because you're bleeding off other companies that are out there. It can be, when it's really congested like that, it can make for a difficult locate. When you get like a bad locate or something like that, and you're curious as to why, because you don't see any signs of why it takes an odd turn or bumps out and comes back. Because sometimes when you get in a locate and it bumps out, you're worried that you're getting bleed off, and now you just bled onto someone else's line or something like that.
With regards to damage prevention and with regards to locating and the ability of bringing, the continued growth technically that we have, what we've been able to do internally is to be able, because we have now locators on staff that are so skill set, to be able to bring locating into the design phase more. Because if we think about this, if we have the ability, as we have with non-invasive excavation, and finding in the design phase, we bring more locating into the design phase and get our clients to understand and the DOTs to understand that if we're able to get more accurate information in the front end of the designs, planning phases, this is going to save not only the construction cost of whether it be a bridge, an interchange, a new road, it's going to be able to save millions of dollars in relocation costs, because those designers for the new infrastructure can design with more information, more accurate information, and that's where we're going to see, and that will create more job opportunities for locators. We're still going to need it in the one-call system in advance, but if we can be able to work this more and to sell this better as a value add, we know it's a value add. It's just, needing to be able to change today's procurement methods for engineering and planning phase services. But I'll be more excited in the fact when we see on all of our designs where we do our surveys now, our more typical surveying work, incorporate that surveying work with locating, and now we're on to a whole new level of accuracy.
One of the things we do have that is really nice that helps is they have a GIS mapping system, and we take all our clients' prints that they have, put it all on this one map, and you could just type in pull up the client you need. It'll pull up all their polygons, and you just type in the address and you click on the polygon and pull that print right up. So there's no more need to have to drive around with a big stack of paper prints anymore. You just pull it right up on the computer, so that helps out a lot too.
New locating technology will work in two ways. First, the locating technician's results populate a centrally managed utility location database. Then, the next time locating technicians visit the site, they will be able to access location information from the database while performing the locate.
Obviously, efficiency is a main part, but safety is the most important, and that's that ability for that piece of equipment that day to have reference points to what past locates were, and to be able to alert a deviation is so important to that locate. There might be a reason why that there's something different on reason, or that allows us then to be able to communicate back, whether it's to a home office, a technician internally that has access to records or the overall database, for them to look at it and to be able to say, stop, let's look at this, reverse, come back and figure out, was it the historical information was not correct, or is it now the fact that, for some reason on that day, that mark is not where, or that tone is not where it should be, or does not compare against the last 10 times.
It'd be nice to be able to pull up a print and you can see, or a map, and you can actually see everybody that's in that area, so you kind of know what you're dealing with. Like if there's a lot of things in the ground, so if all of a sudden your line, makes a sharp bend around something, you could probably see why, what's under the ground that made them go that way. So it would help in certain situations.
If we had a device with that type of GPS accuracy to begin with, it needs to be a very precise positioning. But if you had that and you understand that every time you tone a line there could be that deviation, but you knew the data set you were working from previous was maybe based off subsurface utility engineering that included actual potholes, and so you had a physical measurement, and you had that plugged into your GPS even before you went out there or into your locate wand, you're toning it and it's telling you I'm right on the money on a point that I know is good, or I'm actually deviating off that point. And so you're giving the locator the percentage above what he's actually got today information-wise is huge, something that he never had before.
Sometimes, like I said, the print will show that there's a line running east out of the manhole and there's not. You know, whether it used to be there and they you know, it's an old line that's not there anymore, or it's possibly that it was a proposed line that they were supposed to put in and then they canceled and never did. You know, so, and then we just, when we find something like that, we send an email to our client to let them know that, you know, it doesn't line up, match up with the prints, what we're finding out on the street, and so that they could fix it on their end.
I think a lot of people don't understand how damage prevention begins at the design stage.
Yeah, I think you're right, Ted. I think a lot of people don't understand that. And you know, with new technology and data storage, it's really going to change the future of damage prevention. It's very important to understand how a utility design job works.
So the way that we capture utility data for the purpose of designing either a repair on a utility or new utility infrastructure is the first thing that we do is we put a survey crew out on the street. Because we can't see underground and we can't see what's happening below the pavement, some of the best clues that we've got are the things that we can see from the surface. So we're going to look at everything from, we'll look at pavement depressions that could indicate a historical trench line. We'll look at old faded paint marks that could indicate previous locates, or if fresh marks are down, we'll pick those up. We then bring that data back in, that survey data that's on what we call state plane coordinate systems. So it's as precise and accurate as we can get. And we'll pull the utility atlases. And the utility atlases are a collection of every different utility's kind of take on where their information is. Some are very good and very detailed, and some are very high level and not as detailed.
Even the city's entities actually submit their atlases, be it electronically or by snail mail. After we receive those atlases, we apply those to our base maps, which generally lines up with the locating, with the locate paint and everything. If there are discrepancies, then they're basically investigated in the office via calling the utility companies, the representatives, or coming out and doing a verification.
The next part of it that we'll do is we'll go through each one of those atlases, and depending on the level of information they give us, we'll apply those alongside of those points that we shot during survey. So now we have the lines coming on to the print as well as the structures that we shot during survey, and we start to see things happening. You might have one utility that tells you, I was 5 feet off the curb and it was a 12-inch main, but our survey shows the associated manhole with it 8 or 9 feet off the curb. So now we have questions that we have to answer. Is it because the valve was offset away from the manhole, or is it that the utility information wasn't correct? One of the things that we really believe is that if we were only drawing one utility at a time, we have much less to work with than if we're drawing all utilities. Once we have the depiction done, we'll generally take that back out of the street, do a last field verification and say, is there anything else that we don't see here that we've got reflected? And then it moves into its permitting process where it gets reviewed by the utilities for what we're installing. That's generally the process through design.
I don't physically do any of the design work. I kind of do constructability reviews from the designers that are working on these new projects. So I'll take a look at it once it gets to a certain stage and make sure it's constructible. And then we go ahead and we schedule the design walkdowns with that client to make sure that they're going to be satisfied with the location that we're picking for their new line. and to make sure it's constructible out in the field also, where the contractor's going to have plenty of room to bring their machines in and set up their bore rigs, and making sure that, you know, the area is going to be an open area to build their pipe, you know, just so there's enough workspace in those sections too. So
This is where the rubber meets the road. How does the utility design project impact safety, speed of construction, and damage prevention?
Well, today we're out here on a site. This is a Comcast installation. We're expanding their backbone. So we're installing some PVC conduit for fiber optic cable installation. They're coming out of one manhole, coming up into the intersection where it's congested, then turning and heading down Illinois, and dropping off at 4 different buildings along the way, and then tying back into their system a couple blocks down the road. So what we're doing is we're having to go through and install in a fairly congested area. As we can see them digging, there's not a lot of room already left in the street. They're digging, and you can see some of the congestion they're having to go over or under some of the existing utilities. But they also, if you look down towards Illinois, you can see the congestion of the vehicular and pedestrian traffic that they also have to manage as they're trying to do their work. And the crews can only be out here off rush hours, so that's like 9:30 to 3:30.
I think incentive is a really big question. Ted, you hit on it as well. If you have a contractor who is paid to go out and install a water main, and when they open up that trench, they're opening up essentially a very big pothole full of very valuable subsurface utility information. But they are only contracted to collect record information about that water main they're putting in the ground. And if you said to them, you just passed a gas service, pick up that information as well, they're going to say, I'm not paid for that, it's not my scope. And if you went back to the water department that was paying them to put that water main in, they're going to say, I have no reason to pick up information about another utility. So this is where we can start to look at researching technologies that make that a little bit easier. So one great example would be if I could just walk around that trench that was open to collect information about the utility that I just put in, and was able to turn that picture into a photogrammetric point cloud that also had the gas services in there. Did I just do all the steps I needed to correct my scope, but picked up all the other scope at the same time? And if I have technology to process that data and bring those measurements in, I collected data without any additional effort. And so those are the types of things I think we need to look at in those processes. And then it does go back ultimately to, is there a place to put that data?
Why collect it if there's nowhere to put it?
Right.
Mike, it's amazing how many opportunities there are to collect data about the location of underground lines. In fact, at every job site, there's a chance.
Oh, absolutely. Ted, these lines don't move. A centrally managed database would fill up quickly. People would grab the information and knew they had a place to store it.
Yeah, the contractors are doing that, and so we work with them to communicate, because we're not out here on a full-time basis. We're only out here when needed, but they're out here all the time, and so that's where, as they're putting the conduits in, they're taking measurements to be able to give us the record or installed location of the facilities. We then take those field measurements and then incorporate those into our design file, and then turn those over for records for this, for Comcast to be able to provide future requests for underground installations where their facilities are at. And this is where we're talking about working with them to be able to get additional documentation of crossings of some of the utilities, like when they encountered, to go over them, it's shallow and stuff like that, so we can better understand kind of three-dimensionally kind of where the facilities are at.
In terms of collecting what happens from a record perspective, the crew installing or one of our engineers would go out to the site and take measurements, or actually survey shots depending on the installation, as it goes in the ground, and then we would come back and update our records on that. Now that's really key. We update our records on it and we'll provide those back to the utility, but there's no centralized place that information ever resided. It's then up to each agency independently to update their records with that information. And that's kind of the process from beginning to end.
There's no doubt in which that if we can, and I think everyone in this room agrees, is as much as we can do to move into the planning phase of as much we can understand from subsurface utility engineering to planning, communication with the utilities, et cetera, on the road projects. We are still pushing it too close to construction and you know, I'll speak and I'll take a shot at the engineering industry as we looked at it. And I think that our industry as a whole for a number of years became too much reliant and let our insurance companies and carriers push us down a road of pushing things to contractor responsibility. I think everyone saw that. It was always to don't assume liability in planning phase, push to construction and make it constructor responsibility. Well, what happens with that and the reality is that's pushing everything to a closer time schedule to where there is high pressure, there's just too much riding on that. And then when you expose during the construction phase a conflict, you could set a project back, and I'm sure everyone in the room has seen it, 6 months to a year easily on these things. So yes, we've got to get the design and planning earlier.
It's interesting that I think the insurance industry needs to speak with one voice too, and we don't always do a good job of that because obviously you have professional lines that are covering your engineering costs. Meanwhile, we have casualty lines that are covering our contractors that are putting shovels in the ground. The design professional push that liability off to the contractor. Meanwhile, we're telling the contractor, well, push that liability back off to the designer if you can. So we're talking out of both sides of our mouth because frankly, we don't want to have to write a check for either one of your mistakes. So that's one of the things that we ought to do a better job of. So I think that's an interesting sort of dynamic that takes place here. So this project was an HBK design. So we got all the records together and put them together and came up with a design and the selection of the running line. What the contractors have to do is they have to take and saw cut the pavement at an anticipated location before they start to open it up and see what's in the ground. So they go based on our drawings where they can saw cut to be able to excavate down and to be able to put a new conduit in. If there's something in the way, if we didn't do our job right, then they have to stop, backfill, and move over and cut again, and it takes more time and breaks up more of the pavement. So HBK's project involvement is putting the design together such that we can select a good running line that they can take and install the conduit at the proper depth that the client is asking for, but then also avoid all the other utilities. So that's the struggle that we've been doing, since we started getting into this business. One of the nice things about, or one of the opportunities that HBK has had, is that we've worked very closely with contractors and been able to be in the field and be able to see a lot of the installations and capture that information. Now getting the foremen and laborers to also capture that information more than what they're doing right now, or a lot of them will capture the information, but it's just in their field books, their log books, their cameras, and it goes into a file, and it goes into that and you never see it again. And so we just need to get that to a place that's easy for them to forward it to a central place that then somebody can refer back to it and make some determination or understanding of what to do with that information on the next design. And that's the goal of education that we're trying to get to. Not making it a more laborious or cumbersome process for the people installing it, just maybe a mechanism or a way to capture that information they've already collected.
You're going to open a trench and you want to work with a street, for example. You're going to open up this trench, you're going to cause problems and traffic delays and everything else. It'd be nice to coordinate all the maintenance of the utilities in that area possibly that could work in that common trench and get everybody in there working to get this all solved or set up, and then you get your street nice and paved, and then you don't have to have
now
multiple
you're pushing
people
your
coming.
luck. You're going to.
But I mean, these are thoughts that where you could look at coordination as a something to increase the efficiencies going forward.
One of the things we see in building construction, the building information modeling systems now are huge. I mean, you have a virtual 3D model of a skyscraper, and every pipe, electric distribution line, everything, the sewer, gas, everything is built into that. And I sort of see this heading to that in the underground world, that we're going to have effectively something that parallels these BIM systems. Now, BIM's had its growing pains as we've gone through. We find out that these systems aren't perfect as the systems interact, and when the physical installations come in, we still have interferences that we run into. But the model is out there, right? I mean, these things are being used right now in structural erection, so there's no reason why we can't translate that into something that we're going to do in the underground world.
So design stage damage prevention. There needs to be more of it. And when you understand how damage prevention begins at the design stage, you can really see that we have all the tools right now that we need to lower damages.
Yeah, we're just changing the approach to damage prevention. By adding this technology, it'll make the whole process faster and better.
Absolutely.
One of the bigger questions that we've gotten is, if you put a contractor out who's doing water, what's their incentive to pick up? What's their incentive to pick up any other utility information that's not water? And one of the technologies that we are experimenting with right now is a sort of a scaled down LiDAR, photogrammetry, which allows us to create a three-dimensional model from a series of digital photos. That's a technology we're very interested in because of the scalability of it, and the fact that it's, say, a foreman or a superintendent on a crew could literally walk around their trench as they're excavating it and create the means to make a three-dimensional model. So where you could start to capture not only the dimensions of the utility they're putting in, but also the dimensions of utilities coming across it. So if we look at that in the context of a three-dimensional composite map, if we got data like that we could continually bring in, we're always able to sharpen up and refine those measurements on utilities that were not core to the one being installed.
It's not only for HBK, but let's say for an industry to better promote what we're talking about here today. And it's how do you communicate your successes? And what I mean by that is that this work to drive efficiencies and create designs that are safer, more constructible, we do know that those create cost savings to a region, to an industry, to a specific project. They're just, at times, they're very hard to quantify. And if we do a better job as an industry to be able to quantify the savings that we provided through this new technology, through pushing SUE as related or bringing in more technology earlier on to it, we will see the very large infrastructure projects that are coming down, and, that will be coming down the pipe, down the road, of recognizing that this is a place in which that we can become, that we'll do much better at. And that's been HBK's story since we've had two people looking ways that we could drive safer designs and more constructible designs in an underground environment. Now it's taking it more across an industry and saying we've got to keep this momentum going. The industry has went a long way, as you know, in the last 20 years. But now we have these tools at our disposal, so we've got to do a better job of explaining to those individuals that don't spend their entire professional career in our space, and to be able to better communicate the message. And I think you'll see, number one, a lot of funding open up for our type of work because of the great cost return on investment it has.
Planet Underground wants more things. Intrend, HBK Engineering, and C-Scan.